So compounds are composed of atoms of different elements, and they're held together by chemical bonds. So far we've been talking about them being stuck together like Lego bricks, but what exactly is holding them together? We call those chemical bonds, and these result from attractions between the charged particles that are inside of atoms. So we've studied the internal structure of the atom a little bit. We know that in the nucleus there are protons and neutrons, and around the nucleus there's a cloud of electrons. Electrons have negative charges, protons have positive charges. Chemical bonds result from attractions between these particles, and they happen in two broad categories, two different ways: ionic bonds and covalent bonds. So ionic bonds happen between metals and nonmetals. You don't get an ionic bond between two nonmetals or two metals. You have to have a metal and a nonmetal. And these involve the transfer of electrons from one atom to another. We looked a little bit at ions, right? And we can predict the charges that some atoms take when they gain or lose electrons. So a metal atom will lose electrons and form a positive ion. A nonmetal will gain electrons and form a negative ion. Oppositely charged things attract each other, and that is the ionic bond. The metal becomes a cation, the nonmetal becomes an anion. So they're sticking together much like magnets. It's not magnetic forces, it's electrostatic, but the concept is very similar. So if you imagine one of those magnetic building toys, and you just get the pieces together and they click and they stick and it looks like magic, right? That's sort of what ionic bonds are like. And in the solid state, for an ionic compound, you have a lattice, a regular three-dimensional array, where there's a definite arrangement of alternating cations and anions. Because you don't want two cations next to each other, they're going to repel each other, and you don't want two anions too close to each other. You want to maximize the attractions, and so they tend to go every other one. I think there's a picture, yep. So here we have sodium metal, and here we have chlorine gas. So what happens is this neutral sodium atom has 11 electrons. And remember we talked about the noble gases and how atoms tend to gain or lose electrons so that they have the same number of electrons as the nearest noble gas. So sodium has one more electron than neon, and so it will tend to lose one electron. That electron cannot just be discarded. You can't throw it in a ditch. You can't leave it at the police station. It has to go to something. So the electron has to be given to something or someone. Here's a chlorine atom. Chlorine atoms have 17 electrons. And so they're one short of having the same number of electrons as argon. So the chlorine is motivated to gain an electron. Sodium wants to lose one, chlorine wants to gain one, so they can help each other out. Sodium loses an electron. Now it's got 10 electrons, positive charge. Chlorine gains the electron. Now it has 18 electrons, a negative 1 charge. So they both have the same number of electrons as a noble gas. We've got a positive charge and a negative charge, and now they're very attracted to each other. And so they will stick together electrostatically in this arrangement where you've got anion, cation, anion, cation. And so we go from a metal and a toxic gas to forming sodium chloride, which makes your steak taste better. Any questions? So those are ionic bonds. Covalent bonds happen between two or more nonmetals. Co is a prefix that means sharing. So this involves the sharing of electrons between two atoms. So we talked about nonmetals want to make negative ions. They're going to gain electrons, right? So if you have two nonmetals and they're both trying to gain electrons and they both make negative ions, how could they possibly be attracted to each other? They couldn't, not as ions. It's not going to happen. And also, where would they get the electrons they need to become anions? It's not going to happen. So no electron transfer occurs. The nonmetals are going to share the electrons. So here we have an illustration. Here's the nucleus of one atom and the nucleus of another atom, and this is the electron that they're sharing. If the electron that they're sharing is way over here to the side or more over towards one or the other, that's not going to be the most stable situation. The most stable situation is when that shared electron is exactly between the two atoms. And the shared electron pulls them together, it bonds them together. It's a little bit, like when people share things. If you share a house with someone or you share a car with someone, it kind of, brings you together because you have to cooperate on things. So we call covalently bonded compounds molecular compounds because they form discrete molecules, unlike ionic compounds that are just an arrangement of different ions. Any questions?